Hello guys and welcome to Science Academy, and today's lecture we are going to discuss the topic work, energy and power from the category of mechanics. Obviously this section is for NEET and IIT-JEE students, aspirants. So let's go to the first question. As always, we will be having 5 questions and we will be solving that. So after each question, you have to take 2 minutes, pause the screen, and then you have to check the answers, whether you got the same answers which we have discussed in here, right? So let's start and go with the first question. Yes. So the first question, it says a 20 gram bullet pierces through a plate of mass m1 is 1 kilogram and then comes out to rest inside a second plate of mass m2, right, which is 2.98 kg. It is found that the two plates initially at rest now move with equal velocities. The percentage loss in the initial velocity of the bullet when it is between m1 and m2, right? So there are other things are given, that is the neglect the loss of material of the bodies, due to the action of bullet. Obviously some part of the body, it will be lost, right? A certain amount of. Now let's guys, I will just try to make you understand what exactly this question is about. So we have a body here, a block, and we have another block here, which is one is m1 and the second is m2, and a small m bullet is it passed through here, right, and got embedded here in the second mass, right? So we had to find the loss of energy between here m1 and m2, when the bullet, when it is between the m1 and m2. So this is the loss of energy that we have to find, loss of energy. Let's do this, right? So guys, now yeah. So guys, if you consider, let the initial velocity of the bullet, let's say its mass is anyways 20 gram. I'm just converting it into kilograms, so it would be 0.020 kgs, right? So this is going to be the mass, right? And let's say let the initial velocity of this bullet, let the initial velocity of this bullet of mass 0.020 kg be u, right? Okay. So the initial momentum of the system, P initial, if you consider, I mean, of the system, when I say system, it is going to be the bullet plus the plate is going to be mu. Am I right? Because the plate is obviously at rest, right? So if you want to consider, you can write m1 times 0. So it is anyways going to be 0. So it's going to be mu. Am I right? So the final momentum of the system is going to be m1v plus m2 plus m times v, right? So since why this happened, because the bullet got embedded, right? The bullet of mass m is inside the plate of mass m2, right? So according to the principle of conservation of momentum, we know mu is going to be m1v plus m2 plus m times v. So 0.02u is equal to 4v when we add the masses. So u is going to be 4 by 0.02, which is actually 200v. This is going to be your equation 1. So let v1 be the velocity of the bullet as it comes out of the plate m1, right? Let's say it's m1, the bullet that comes out, let it be v1, the bullet's mass over here when it comes out of the plate m1, right? So by conservation of momentum, we know mv1 is going to be m2 plus m times v, right? So 0.02 v1 is going to be 2.98 plus 0.02 times v. So v1 is going to be 3 divided by 0.02, which is 150 v. That's going to be equation 2. So the change in velocity, the percentage loss in initial velocity of the bullet, let's say u minus v1 by u times 100. This will give you the percentage energy change, velocity change. So 200v minus 150v by the initial one, 200v times 100. This is actually 25%, and this is going to be your answer, right? So what's our option? We have an option that 25%, that's going to be our option B. So guys, option B is the answer. I hope this particular part is clear for you guys. So I already believe that you guys took that 2 minute, to solve this question and check whether you got the same answer or not. Now guys, let's go to the second question for us. A bullet of mass 20 grams hits a block of mass 1.98 kgs. So take another color. Yeah. So there's a bullet and it has a mass of 20 grams and this has a mass of 1.98 kgs. Okay. Suspended from a massless string. So the string is massless, so you don't have to consider the tension there. I mean the mass of the string there. And its length is given, which is 100 centimeter, or I can say 1 meter, and it stick to it. This bullet that it just hit here and stick to it. When it stick to it, what happens? It moves, right, in this way. It moves and reaches some height h, isn't it? So we had to find this h. This height is what we have to find. Also, they have mentioned that the velocity, the horizontal velocity of the bullet was 200 meter per second. 200 meter per second. If we know that this is 30 degree, which we know from this, we can understand this is also 30. So this is going to be v cos 30, and this is going to be v sine 30. So these are the things that we can infer from the you know what's given in the question, the information. Now let's discuss this question. It's actually kind of a simple question, guys. You don't have to think a lot to understand this question. Clear? Sorry. Yeah. So guys, let's discuss the question. Yes. So here, right, let's say that the horizontal component of the momentum of the bullet is equal to the momentum of block with the bullet. So we can simply say mu cos alpha is equal to m plus m times v, isn't it? Let's consider this equation 1. Similarly, yeah, yes, okay. So if you just have any confusion that what is this v, right? So this v is actually the velocity of the block plus bullet embedded in it. So when we have the block, right, and we have this block and the bullet there, and the combination of this thing, it is moving with the velocity v, so that's the velocity v here, right, v meter per second. Don't get confused, guys. Now when the block can move as a pendulum kind of thing, we can use energy conservation, right? That means v squared is equal to m plus m times gh. M plus m and m plus m gets cancelled, isn't it? So this consider equation 2. From equation 1 and 2, you get h is equal to m by m plus m the whole square times u squared cos squared alpha by 2g, right? Or rather we can get it as 20 times 10 to the power of minus 3 by 2 the whole square times 200 square m cos squared 30 by 2 times 10, so which is going to be 0.15 meter. So the correct answer is option A. So we got the answer, that is option A. Clear? Let's go to the third question, which we need to discuss here, that a particle of mass 4m which is at rest explodes into 3 fragments. Two of the fragments, each of mass m, are found to move each with a speed v, making an angle 90 degree, okay, with each other. The total energy released in this explosion is, so we will just discuss it. guys, take 2 minutes, solve it by yourself. Okay, so we have a mutually perpendicular. This is mass m, this is mass m, this is mass 2m, right? Yes or no? Two of the fragments of mass m and the second one moved with the speed v, and the angle is 90 degree, that is given in the question. So it's kind of orthogonal vectors, the velocities are, right? So v and v is going to be v root 2, parallelogram law. So we can, the total energy released in the explosion is going to be half mv squared plus half mv squared plus half times 2m times v by root 2, sorry, v by root 2 the whole square, that is going to be 3 by 2 mv squared, 3 by 2 mv squared, right? Hmm. So because if you consider, guys, here this is mv and this is mv, right? So this is going to be root 2 mv, and according to the momentum conservation, this as well as this, if you consider, root 2 mv is equal to 2m times v dash. This v dash is what we have to find. So that v dash is going to be, it is going to be v by root 2. That's how we got v by root 2 here. Clear? So our answer is 3 by 2 mv square, and 3 by 2 mv square, we have an answer, and the correct option is option C. So option C is our answer. Option C. Clear? Now let's go for the next question. A slow moving electron, where is the slow moving electron collides elastically with hydrogen atom at rest. The initial and final motions are along the same straight line. What fraction of electrons' kinetic energy is transferred to the hydrogen atom? The mass of hydrogen atom is 1850 times the mass of electron, right? So guys, if you look at the question, let's consider that m1 and m2 be the masses of electron and hydrogen atom respectively. Let's consider m1 and m2, and u1 and v1 be the initial and final velocities of electron. The initial and final velocity of electron. Then the initial kinetic energy, we can write it as half times mu1 square. I'm sorry. Yeah. And the final kinetic energy is going to be half m v1 squared, right? Then what is a fractional decrease in kinetic energy? Kinetic initial minus kinetic final by kinetic initial, which is 1 minus v1 square by u1 square. Consider this is equation 1, right? For such a collision, we know that v1 is equal to m1 minus m2 by m1 plus m2 times u1, right? Therefore, you know this v1 by u1 is going to be m1 minus m2 by m1 plus m2. This is equation number 2. So from the equation 1 and 2, you will get Ki minus Kf by Ki. The change in energy by initial kinetic energy is 1 minus m1 minus m2 by m1 plus m2 the whole square. That is 4 m1 m2 by m1 plus m2 the whole square. Or you can write Ki minus Kf by Ki is equal to 4 times m2 by m1 by 1 plus m2 by m1 the whole square, which is 4 times 1850, the ratio is given there, plus 1 plus 1850 the whole square. On solving, you will get it as 0.00217 or 0.217 percentage. So the correct option is going to be option A. So option A is our answer. Clear? Let's go to the final question. A chain of linear density 3 kg per meter and the total length is given as 8 meter is lying on a table with 4 meter of chain hanging from the edge, which means 4 meter is here, this is 4 meter, and the 4 meter is here, hanging from the edge of the table. Let's consider this a table. My drawing skills are pretty poor, guys, so try to understand that. So the work done in lifting the chain. So this chain, we have to lift it in this direction, back to the table. And what is the total energy required for that? So, I mean, total work done basically. This is the thing what we have to find. Let's say how we can do it. So let's consider the mass of hanging chain. How we can find the mass of hanging chain? Because the linear density is 3 kilogram is given, right? Which means lambda, which is actually equal to mass by length, is 3 kilogram per meter. Then what is the mass of that 4 meter which is hanging? That is equal to lambda times 4, which is basically 3 times 4, which is 12 kgs. Am I right? So 12 kg. So shift in the center of gravity. So we know the shift in center of gravity is going to be 4 by 2, basically 2 meter. Why? The reason being, guys, listen here. If you think about this is our table. I'll take another color for your understanding, guys. Yes. So we have this color is pretty bad. Okay, it is fine. Yeah, this is a chain, and this is 4 meter, right? And this chain you can see here, this is also 4 meter. But what you should understand here is this is the mass from the weight actually acting downwards from the center of mass. So that shift actually happens only for 2 meters because half of the length, right? So that's 2 meters. So what is the work done? Basically, we have to find, we know the work done can be given by mgh, and which is equal to m is 12, sorry, 12 times g is 9.8 times height, the is the this h is basically the shift in center of mass, the shift in center of mass. So the answer is going to be 235.2 joules. Do we have an answer? 232.2 joules is our option B. So the correct option here, which we need to round, is option B. So that's our answer, right? So guys, I hope that work energy power, we have mainly discussed the problems based on the work energy theorem. Most of the questions are based on work energy theorem except the last one, hopefully. So work energy theorem and momentum conservation, if you know this well and good, then your exams, the questions that you receive from this part is going to be easy for whether the exam is NEET or whether the exam is IIT-JEE. Clear? So I hope you guys understand this completely, and I hope you guys enjoyed the video. So please do subscribe the channel, share with your friends, like the video, and what you like and what you do not like. For any improvement, please comment below. Thank you guys. Thank you so much. See you in the next video. Bye bye.